Okay guys, and welcome to the next video. Now this video here is the first of 6 videos for unit 1.5 and what is soon to be the old syllabus, okay? And it's about production and cost for paper 3, which is again soon to be the old paper 3. Alright, so now the very first question that I want to look at, and we have kind of looked at this stuff before, is that an increase in cost of production has resulted in a new supply function of this. Now obviously we've answered that in other questions, so I don't want to dwell too much on stuff that we've already done in other videos, excuse me, not questions. Outline the reason why an increase in cost of production has resulted in a new supply function. Okay, so this is one of the ones of this old paper 3 where you have to know a bit of theory. So an increase in cost of production will reduce the profitability. And what that means is, that is reduce the profit margin per goods sold, okay? Now what that does is that causes producers to be less willing to supply the good at each price. And this causes an inward shift in the supply curve. All right, so that's the very first question there. I'd hope you'd be familiar with that at this stage. Okay, now calculate the average cost of production if all tickets are sold. Now, excuse me, it's the average fixed cost of production. Well, we need to know what the fixed costs are, and we said the fixed costs for the concert have been calculated at $3 million. Actually, I suppose I should give you a bit of background on this question too. A music concert to take place in country Z, right? And 40,000 tickets are available for the concert. And figure 3, which is down here, shows the demand. Now again, I'm omitting those questions because they're not to do with cost. So it says there's 40,000 tickets, fixed costs are $3 million, and calculate the average fixed cost per ticket if all tickets are sold. Well, what we've got here is the definition, or well, one form of a definition, which is the formula for average fixed costs. And what average fixed costs are fixed costs divided by quantity, okay? That's how you work it out. Now, so basically what we're saying here is that the fixed cost we were told in the question was 3 million, and the quantity that was demanded, I suppose, if all tickets were supplied, if all tickets were sold, is 40,000. So what we've got here now is we've got 3 million divided by 40,000, okay? And that's how you calculate average fixed cost, the fixed cost divided by the quantity, and you'll be given that in the question. Now, I've just got all the answers here, but of course you guys should take out a calculator and stuff like that, and the answer is 75. And all I'm just going to do here, just to be kind of overly complete, is write down answer average fixed cost equals $75, okay? That's what we're writing down there. Now, on to the next question here. So we're given this diagram about firm A. So we're saying firm A produces cartons of coffee. Figure 1, which is this one here, illustrates firm A's total cost and variable cost at different levels of output. Okay, now the thing is, it says calculate firms A average fixed costs when it's producing 125 cartons of coffee per month. Now what I shall do is give you the definitions in words, okay? So what we're saying here is that fixed costs are costs that remain the same irrespective of the level of output. Variable costs are costs that change as a result of changes in output. And total costs are fixed costs plus variable costs. Okay, so fixed costs, how to calculate them is total cost minus variable cost. And the easiest way to do that is to go to quantity equals 0. And what we have here is that we've got total costs are 500. Those total costs are made up solely of fixed costs. And that's not the only way you can calculate, but I just think it's the easiest. It's the distance between the two, okay? It's because it's fixed costs, there's total cost minus variable cost equals fixed cost. So what we're saying here is that variable costs at a quantity of 0 production are 0 because they change as output changes. They're 0 at 0 production. So when you're making nothing, your variable costs are nil, but you still may have fixed costs. Most likely you do, okay? So what we're saying here then is, well, we have to calculate fixed costs first. So we're going to write FC equals, well, total cost, which is 500, minus variable cost, which is $0, okay? And I hope you don't have to be a mathematical genius to work out that that's 500. Now, that's our fixed costs here. Now, what we want to do is calculate average fixed costs at a quantity produced of 125 units. Well, we use this formula here like we did in the last question, which is your fixed cost divided by quantity. Now, fixed cost will always change as quantity, or sorry, that's a lie. Fixed cost will always stay the same as quantity changes. Average fixed cost will always change as quantity changes. So what we've got here now is 500 over quantity, which is 125, and I just worked that out as $4. Okay, so I'm just going to write down here answer. Okay, average fixed cost equals $4. Okay, now all you needed was just the answer, but I'm trying to make this stuff as obvious as possible. Okay, and I hope all of that helps. Now we're on to this question here, which is 2b. Calculate firm A's average variable cost when it's producing 125 cartons. Right, well what I've done now for this question is that I've just written down average variable cost is variable cost divided by quantity. And I could say that the variable cost of 125 is 1,500, but that's no use to you. So what we've got to do now is go back here and realize how we work this stuff out. So if I go to here, which is the quantity of 100, not exactly, but the quantity of 125, and I get my ruler out and I go straight up, yeah, to the variable cost curve. What I actually get then, if I go across to the currency curve, I suppose, just try and be accurate, take your time when doing this, is I get the variable cost, the total variable cost, if you want, at a quantity of 125, and I have that as 1,500. Now, to get the average variable cost at a quantity of 125, I have to take my variable cost, which is 1,500, and divide it by 125, and that's what I'm just doing right here. Now, just getting my cheat sheets together. So what I have, yeah, absolutely. Okay, so what I have here now is 1,500 divided by 125. Excuse me. And what I get then is I'll work it out here, is 1,500. Oh God, you can't see that, I'm sorry, can you? A little bit better if I go further down. Divided by 125, and that equals 12. Okay, so what I've got now is 12. Now, so that means that the answer, the average variable cost equals $12 at a what? At a quantity of 125 units. Now, you must forgive me guys, I've lost my place here, but I hope to find it again. Now, we're doing okay. All right, here we go. Very good. Okay, good. All right, now, sorry, we're on to question 2C. So what we're saying here is figure 2 illustrates the average total cost, ATC, okay, of and the average variable cost and the marginal cost at different levels of output for firm B, which produces cans of tea. Now, I will just try and refocus the camera. Okay, so using figure 2 up above here, calculate the average fixed cost when 80 cans per month are produced. Okay, well what we're saying here is that the average fixed cost equals the average total cost minus average variable cost. And what we've got to do now is we're saying at 80, right? So if we go up from this here, and I'll actually use a red pen just so you can see it. Always use pencil, guys, in your exams, okay? So I'll use a red pen because I think it'll just come up easier on the camera. All right, now if I go across from here, from the average variable cost curve, that's the AVC. So at a quantity of 80, if I go across the AVC, I have an average variable cost of $20 per can at a quantity of 80. Don't forget it changes, of course. But if I go to the average total cost, okay, well, I have $25 per can average total cost. Now, if coming down here to the workings, if I take the average variable cost away from the average total cost, I'll get the average fixed cost. So what I just write down here now is I write an average fixed cost equals average total cost, which is up there at 25, and we work that out up the top, you can still see that. And I take away the average variable cost, which is 20, and I get an answer of 5. So what I'm saying here is average fixed cost equals $5, and if you want to be absolutely accurate, at a quantity equal to 80 units. Now you do not need to write that in, but that's just to kind of highlight that average fixed cost and average variable cost change as we go on. Now, okay, on to question 2D. All right, so it says, oh sorry, that's not it at all. No, we're over here. Okay, so it says using figure 2, which I'll come back to in a second, calculate the total cost when 55 cans per month are produced. Right, well what we're saying is if we go up here, right, from 55, and I shall do this maybe in a blue pen. If I go up here, and this is kind of ridiculous, but you'll see why they chose 55 in a second. All right, so if I go up here from a quantity of 55, and where am I going up to? Well, I'm going up to the average total cost. I suppose that's probably the reason why we always mark in pencil, guys. I'm going up to the average total cost. And if I go across, we're saying at a quantity of 55, each good on average cost the firm $30 to make. Okay, so if each one cost $30 to make, okay, the total cost equals average total cost, which was $30, okay, well, and we made 55 of them, well, the total cost is one by the other. Okay, so what I get here is when I work this stuff out, total cost equals, in dollars, 1,650. Okay, now if you want again, ANS answer, total cost equals 1,650. Okay, I hope all of that makes sense. You need to be very, very certain on how to calculate all of these things, what the relationship with the mathematical formulae are for all of this stuff. Okay, so if you're not sure, always check Cognitive or usually we'll just watch these videos, I suppose. Okay, explain why in the short run, not in the long run, but in the short run, as output increases, marginal costs typically decrease then increase. Well, let's define what marginal costs are. Marginal cost is the cost of producing one extra unit of output, right? Now, at low levels, in the short run, what happens? Why do the costs of producing one more of the exact same good fall and then increase? Well, we have to look at this idea of marginal product, okay? And it's the change in total production when one more unit of a factor of production has been added. All right, so how much does total output change if we hire another worker? Does not always have to be another worker, but we're going to be talking about it in this case. So marginal product, the extra stuff that is made as a result of hiring one more worker, it initially tends to increase at low levels of output. Well, why? As you have one worker, that worker is doing every single job. And as you employ more and more workers at low levels of output, so obviously one worker is the lowest you can have, right? Well, I suppose 0 workers you could, but it's still very, very low. As you start to employ more workers, each worker most likely either under their own initiative or under the direction of a boss or manager will tend to specialize in producing one good. And we get something like the Henry Ford production line kind of going. So because of specialization of labor, because each of them, I said one good, each of them specializes in one stage of the production process. Through specialization, each of those workers get more and more efficient because they're constantly practicing the 1, 2, or 3 roles that they have. They're constantly at that one stage of production, they're just doing that. So they become specialized and that's very, very good. So at low levels of output, due to MP usually rises, marginal product tends to rise at low levels of output because of an increased degree of specialization of labor. However, due to the existence of a fixed factor input. Now, so let's say they're all using these 3 machines. If you have 3 workers, that's on average 1 worker to a machine. If you have 60 workers, that's on average 20 workers to each machine. They have to share these machines. Okay, so we're adding workers, but we're not adding extra machines. So the waiting time increases that each worker has to wait for each machine. The efficiency falls because there's a lot more downtime that each worker spends not producing goods and services, but waiting on the machine. So diminishing returns causes marginal product to fall. As marginal product fall, the additional cost of one more unit of output will begin to increase. And that's what marginal cost is. So therefore, marginal cost increases. 2E, we're on to 3A now. Okay, now, sometimes I give a bit of extra definition and stuff like that. 3A is not really an example, but 3B certainly is. Okay, so define the term increasing returns to scale. So what increasing returns to scale means? Basically, if I put, and I will read it properly, but if I increase all inputs by 10%, total output, total production, so if I increase the number of workers, the number of machines, the number of land, and the number of enterprise, if that's even possible, but all factor inputs by 10%, total production will rise by more than 10%. That's what that means, okay? So increasing returns to scale occurs when an increase in all inputs, all the things we use to make stuff, leads to a proportionately greater increase in output. Now you can stop there, or you could go on, or you could just give the second half. I don't see any problem illustrating your point well. This means that an increase in all inputs by 10% leads to a greater than 10% increase in all output. Okay, that's increasing returns to scale. And there are reasons for it that we don't really need to go into now. Now, just in the spirit of completeness, and I hope you can see that, I think you can, just it's not the biggest writing, this table up here at the top. Okay, and I'll just, there we go. Okay, so what we're saying is, using the data in table 1, which is this table here, to support your answer, identify how changes in inputs may result in constant returns to scale and in decreasing returns to scale. Okay, well, I gave the definition here just so you could understand it better. You do not need to write down the definition for a question like this. I just want you to know what it is. So constant returns to scale occur when an increase in all inputs, all the factors of production, leads to a proportionate increase in output. What does that mean? This means that an increase in all inputs by 10% leads to output increasing by 10%. It's constant. Whatever you increase, whatever percentage you increase, if you double inputs, output doubles. It's the exact same. Okay? Now, looking at this, where can constant returns to scale be seen? Constant returns to scale are seen when output increases from 3,000 to 4,000 units. Well, let's examine what's happening to all of the inputs: land, labor, and capital. Right? So land increases from 3 to 4, that is a 33% increase. Okay, labor increases from 60 to 80, that is a 0.333% increase. Capital increases from 18 to 24, that's a 33.33% increase. And output increases from 3,000 to 4,000, that is a 33.33% increase. So all of the factors of production, obviously you can't measure enterprise in this manner, but all of the factors of production increased by a third, and output increased by a third. So therefore there's constant returns to scale. The reason being that inputs have increased by 33%, okay, and also output has increased by 33%, right? So that's the first one there, guys. Now, I will have to refer to the table again, though. This is the definition which you don't need, and I am only giving this to you to help you understand. Decreasing returns to scale occur when an increase in all inputs leads to a proportionately lower increase in output. Output doesn't have to fall for there to be decreasing returns to scale. It just doesn't increase by as much as the increase in inputs did. Okay, this means that an increase in all inputs by 10% leads to a lower than 10% increase in output. Right, well, let's look at this. Decreasing returns to scale can be seen when output increases from 4,000 units to 4,800 units. Okay, well, let's have a look here. We are moving from here to here. Okay, well, land has gone from 4 to 5, that's a 25% increase. Labour has gone from 80 to 100, that's a 25% increase. Okay, and capital has gone from 24 to 30, that's a 25% increase. All inputs have increased by 25%. But on the other hand, output has gone from 4,000 to 4,800. Right? So that's 800 over 4,000 multiplied by 100 over 1, and that is an increase of 20%. Inputs have increased by 25%, but output has only increased by 20%. So the increase in output was a lower percentage, a lower proportion than the increase in inputs used to cause that extra output to be produced. Inputs have increased by 25%, but output has only increased, and I'm not being flippant about it, but has only increased by 20%. That's what diminishing returns to scale is, or are, I suppose, however you want to look at it. Okay, now the next thing is a firm is making handmade shoes, and this kind of just has a lot, the part B to this question has a lot of simple math, and you're well able to do it, guys. A firm making handmade shoes is concerned with its productive efficiency. Okay, there's a certain definition to what that is. We'll come to that later on. The management has looked into the production levels using different quantities of labour, and the product and cost data are set out in the table below. Well, thanks very much. All right, now outline the difference between fixed and variable costs of production. Now, I have said this already, delighted to say it again. Variable costs are costs that change, that says change there, you must forgive my chicken scratch from time to time, as output changes. Whereas fixed costs are costs that remain the same as output changes. Okay, now, this may look difficult. I promise you it's not, okay? I just need to kind of adjust this so we can see it. All right, we're looking good if it's a little bit skewed, but I can fix that. Okay, so what it's saying, using the data in the table below, determine the marginal product for the different quantities of labour. So as we hire one more unit of labour, how much does total output change? Okay, now, what you will see is that we go from 0 to 1 to 2 to 3 to 4 to 5. Okay, now, but what you can see is some from 0 to 4 and then from 4 to 8 and so on. So what I've done is I've just given you the total, the overall, the formula that will work no matter what one you're doing. So the marginal product, okay, of labour equals the total amount that was produced after you hired the new worker minus the total amount that was produced before you hired the new worker. All right. Now, if we're only hiring one worker at a time, the difference between these two will be 1, and they are only hiring one worker at a time, so the difference between these two will be 1, quantity of labour. But let's say if they hired 4 at a time, they'd have to average out the marginal product of those 4 workers. So it would be the total product after you hired those 4 workers minus the total product before you hired them, and then QL2 minus QL1 would be a difference of 4. Well, what I'm just going to do now is I'm just going to slip over here and go MP1, marginal product, if you want, of labour, MPL1, right, equals, well, what was total product after we hired the first guy? Well, it was 5. Before we hired the first guy, 0, over how many people did we hire? Well, what was the second quantity of labour is 1, and what was the first quantity of labour? Well, it was 0. So basically what we have here is 5 over 1, which equals a marginal product of 5. Now, I like to write it here, but I'll just show you how the IB like you to write. They like you to write it in between when you're talking about marginal product, but I mean, you're not going to lose any marks over that. All I'm saying is total product went from 0 to 5 after we hired one extra worker. How much extra stuff was that extra worker responsible for? Well, he's responsible for 5. He's responsible for all of it. Okay? Now, the thing is, we can go here, MP2. Okay? And that equals 12 minus 5, total production after you hire the new worker, minus total production before you hired it. And how many people are working now? 2. And how many people were working beforehand? 1. And I know that this is always going to be 1 on the bottom line, but I'm just going to show you, okay? Which is 7 over 1, which is a marginal product of 7. Now, what is this saying? What we are claiming is that total output went up by 7 units after the second worker was hired. So in a way, we can claim that that second worker was responsible for 7 extra units of output. Now, more accurately, what most likely happened was these 2 workers kind of divided out the work between them and specialized, and through that specialization, total output increased. Okay, MP3. Okay, so its total product was 16 minus 12. 16 here, total product after you hired the guy, minus 12, which is total product before you hired the guy, and we have 3 minus 2, which equals 4 over 1, which equals 4. Now, what has happened to the extra output that was produced as a result of hiring one more worker? It initially went up at low levels of output, and then it started to fall. And why? Because now the law of diminishing marginal returns is set in. There's too many variable factors of production, workers, that are waiting around and sharing too few fixed factors of production, like machines or capital in general. Okay, MP4. So we've hired another guy. Okay, well, it's 18 minus 16, 18 minus 16, and yes, I am aware I don't have to keep doing this, but it's 4 minus 3, okay, the quantity of labor 2 minus the quantity of labor 1, which is 2 over 1, which is 2. So again, what's happening? The law of diminishing marginal returns is getting worse and worse and worse. Okay, so the marginal product of the fifth worker is 19 minus 18 over 5 minus 4, which equals 1 over 1, which equals 1. The second worker was responsible for an extra 7 units being employed. The fifth worker was only responsible for an extra 1 unit. And you must forgive me, I just realized you couldn't see that calculation there. But there we go. Was only responsible for an extra 1 unit of production. And what has happened there? Well, basically what has happened was it's nothing to do with laziness or hard work of each worker. What it's actually to do with is sharing fixed factor inputs. Okay, the ratio of labor to capital has gotten too high, or the ratio of capital to labor has gotten too low. And the only way to reverse this trend for a period of time after we were to continue to hire more workers would be to add more capital, add more fixed factor inputs that they are currently sharing. So that's what we have there. Now, using the data, which I shall look at now in a second, just forgive me while I set this up. Using the data in the table, okay, draw a graph to show the relationship between the marginal product and labor input. The axis and curve must be labeled. Well, the first thing we've got to do is label the axes, right? So I'm going to write down here marginal product on this axis. And then on this axis, I'm going to write down number of workers. Now, I hope that makes sense. Okay, so where am I going to get these figures from? Well, I'm going to go back to the table. I'm going to say the marginal product of the first worker was 5. So for 1, I'm going to go up to 5 here. Okay, and the only reason I'm using pen on my graph, do never ever use this, is so you can see it easier on the video. For the marginal product of the second worker, it's 7. Okay, so I'm going to go up to the number of worker number 2 and clearly mark 7. All right, going back here, the marginal product of the third worker is 4. All right, so I'm going to go to my graph, going to say this is the third worker because this was the number of workers, going to go up from here and go 4. Okay, the marginal product of the fourth worker was 2 and the fifth worker was 1. So the fourth worker is here and the fifth worker is here. Now again, the only reason I was using pen was to hopefully make these dots stand out, guys, okay? So what I'm going to do now is take my own advice and actually use pencil. Okay, and now usually, I mean, economists like lovely soft curves and stuff like that, but the IB don't seem to worry too much about that. So basically you can just join the dots in this manner here. Okay, and this is the marginal product of labor. Okay, now, so we've answered that question 4C, nothing written there. On the graph, in your answer to the previous one, identify the spot where diminishing returns set in. Well, what does diminishing returns means? It means that the marginal output, the extra output caused by the last new worker employed, begins to fall. And basically, and again, do what I say, not what I do. Never use pen. Diminishing returns. I can't write and talk at the same time. So it's that one. It's on the second worker that diminishing returns starts to set in, guys. Okay, so I really hope that makes sense. Now, okay, so what are we on now? We were on 4D and now we're on 4E. Okay, let me find out where I am because I don't seem to know. Excellent. Okay, now, so it says state the equation used to calculate average total cost and marginal cost. Well, average total cost is simply total cost divided by quantity. There are many other ones. Average total cost equals average fixed cost plus average variable cost. But still, we'll just stick with the easiest one. And marginal cost equals the change in total cost over the change in quantity. Okay, so that's what we have here now. So what I'm saying to you is that we now need to use both of those in conjunction with this table and try to calculate essentially the marginal cost for all of these separate quantities and the average total cost for all of these separate quantities here. Well, I'll just quickly, just for the first one, just kind of come back down and say, okay guys, remember what the formulae are. Average total cost equals total cost divided by quantity, and marginal cost equals change in total cost over the change in quantity. Now, what I'm going to do is I'm going to just do marginal cost first. So I just want to make sure you guys can see what I'm writing, and I think you can. So we've got marginal cost. We're using this formula here. Okay, total cost, right? The second total cost 80 minus the first total cost is 56 over what now? Quantity 2 minus quantity 1. Well, quantity 2 after we've hired one more unit of labor is 5, and quantity 1 when we had no labor was 0. Okay, so what this now becomes is 24 over 5, and what I have is 4.8. So what I'm going to do is, again, because it's marginal, I'm going to put 4.8 there. Okay, that's the marginal cost. Now, I am going to write marginal cost 1. I don't mean it is the marginal cost of one unit. What we really should be writing is marginal cost 5, because that's the marginal cost of the 5th unit, and flip it, I will. Okay, now on to the next one, marginal cost of the 12th unit. Well, how much was total cost? Well, it was 104. We're going to take away 80, okay, and then what was the change in quantity? Well, it was 12 minus 5. So it's 12 minus 5, right? So that is 24 over 7, which I work out as 3.428. So what I'm going to put up here is 3.43. Just round it off to 2 decimal places. Now this is where it gets awkward because I'm going to be flipping back and forth, okay? So let's have a look at the next one. What's the next one say? Well, the next one is the marginal cost of the 16th unit. Okay, so it's 128 minus 104 over 16 minus 12. Okay, so this is where I'm getting these numbers from. Okay, 16. Okay, the 16th unit, 128 minus 104 divided by 16 minus 12. That equals 24 over 4 equals 6. So what I'm going to do now is just put 6 in here. That is the marginal cost of the 16th good. I don't know why they want you to do it like this, but anyway, I'm doing it just to keep them happy. Okay, so the next one is total cost is 152. This is the marginal cost of the 18th unit of production. 152 minus 128 divided by 18 minus 6. And guys, don't forget, we're using this formula here. Okay, that's marginal cost. Okay, so what do we have here? Sorry, what was this? Instead of 4, it was 18. Okay, so the marginal cost, 18th unit, equals 152 minus 128 all over 18 minus 16 equals 24 over 2, which equals 12. That means the 18th unit cost us $12 to make. And the last one is 176, and then there's 1 on the bottom. Okay, so it's marginal cost of 19th unit equals 176 minus 152 all over 19 minus 18 equals 24 over 1, which equals 24. The next unit costs us $24 to make, okay? And as we can see, marginal cost is rising because marginal product is falling. Now, in order to calculate average costs, sometimes I write average costs, it's ATC or AC. What we have to take is total cost, and obviously we can't divide by 0. So it's total cost and divide it by quantity. So it's TC over Q, which is what I have here. Okay, so just kind of looking at all of this stuff, and I've got my cheat sheets here, but I'll just go to show you. So average total cost 5, okay, equals 80 divided by 5 equals $16, okay? On average, when we made 5 goods, each of them cost us $16. Okay, now what's the next one? 12. Okay, so then we've got average total cost 12, okay, is 104 over 12, which equals 8.667. Okay, where am I getting those numbers? 104 divided by 12 is 8.667, 8.67. Okay, just round to 2. The next one, the average cost of 16 units, okay, is 128 divided by 16. Okay, so the average cost of 16 units equals 128 divided by 16, and that comes out nicely as 8. Okay, so what we're just going to do then is flip this over, put 8 here, and then the last one, average cost of 19 units is 176 divided by 19. Have I done something wrong? Yes, I have done something wrong. You must forgive me. I got ahead of myself. There we go. So it's 152 divided by 18, and that's the average cost of 18 units. Equals 152 divided by 18, and I get that is equal to 8.444. So what I'm going to do now is just simply round it off to here, which is 8.44, and then have I done it again? Yes, I have. I've done it again. Excuse me. 0.4. That's why it's confusing. Like if you just put the marginal cost in the right place. But anyway, and then the last one is 176 divided by 19. Okay, so I'm just going to average cost of 19 units. 176 divided by 19, and I need to get my cheat sheet together, and that is 9.263. Right down here equals 9.263. Okay, so what we should be noticing now is 9.26. What's happened? It's falling, right? And then it starts to rise again. All right, and that's what has happened there. Now, like maybe take a photo of that, guys, just the finished article. I really do hope that all of that helped and that, you know, it's clear what we're doing here. But anyway, just take a photo of that because I'm going to now draw a graph of that. Okay, so now what we're saying here is, looking at this question 4G, it says, using your answer from 4F above, which is this one here, this table, okay, draw a graph to show the firm's average total cost curve. Well, what I've got to do now is I've got to put all of these numbers, and let's see if I can kind of position this well enough. Maybe I can, maybe I can't. Okay, somewhat. No, maybe not. No. Well, I tried. Okay, so what we've got here is average cost. Okay, and what we've got here is quantity. And I just realized you couldn't see what I was doing. Okay, so what I'm doing now is I am taking the figures from this here, all right, and then I am using at these quantities. So at 5 on the horizontal axis, I'm going to put 16. Okay, so we go up to 5, and again, just something ridiculous like that, but we'll kind of eyeball it as there. Okay, then what I'm going to do is at 12, I'm going to put 8.67. Now, you'll see how ridiculous this gets. 12, I mean, that's 9, so I'm kind of guessing something like this here. Okay, then, because where am I getting it? It's the average cost of the quantity. Then at 16, I'm going to put 8. Okay, so that's an easy one. I can do that. 16, that's 8. Okay, average cost with the quantity. All right, at 18, 8.44 may have well been flipping, I don't know where. I think that's 9, so I'm going to something like that. And then at 19, I'm going to put 9.26. So at 19, it's 9.26. I don't know. I think that's there. So basically now, again, economists like really smooth curves, but in the IB they don't seem to be too worried about it. So what you can just do here now is kind of join the dots. Now, you really shouldn't be doing that, but still, anyway, if they say it's okay, it's okay. All right. And that's the average cost curve, okay? ATC. Okay, fantastic. Nearly done, guys. Okay, so define this idea of productive efficiency is one of the final few. I want you to understand that if one firm is producing its output at a lower average cost than another one, they are by definition more efficient. Okay? The reason is they are using less of society's scarce resources per good produced. That's efficiency, all right? So what productive efficiency is, it occurs when the firm produces that quantity at the lowest point. It's the quantity that they're producing at the lowest point of the average total cost curve. Now, where does that? It occurs where marginal cost equals average total cost. So productive efficiency occurs where marginal cost equals average total cost. 4I, explain the law of diminishing returns. Explain how the law of diminishing returns affects the firm's marginal costs. Okay, well, if marginal product MP increases, now I just want to make sure I'm doing the right thing here, and I am. Okay, if marginal product MP increases, this causes marginal cost to decrease, and vice versa. Your costs fall when efficiency rises. Efficiency is output per worker per hour. If extra workers start to produce less output than the previous workers employed, your marginal product is falling. That manifests itself as an increase in costs because you have to pay another worker to do less work than the previous one did, and you still have to pay them their full wages. As diminishing returns sets in, for a given increase in a variable input like labor, so you hire another guy or hire another worker, okay, the resulting increase in output becomes smaller. As a result, the additional cost of one more unit of output, which is the definition of marginal cost, will begin to increase. Now, finally, guys, explain one possible source of economies of scale that this firm might benefit from if it increases its scale of production. There are millions of them, okay? I have just gone through 3 here, okay? The first one is bulk buying. As firms increase in size, they are often able to negotiate discounts with their suppliers that they would not have received when they were smaller. The cost of their inputs is then reduced, which reduces their unit or average cost of production. Economies of scale are, by definition, the reduction in the long run average cost as a firm or industry grows in size. As you get bigger, what does getting bigger means? Producing more, selling more. As that happens, you're going to buy more inputs. As you buy more inputs, you can say, look, I was giving you, 100,000 a year. Now I'm giving you 1 million a year. I think you need to give me a better deal. Otherwise, I'll go somewhere else. And they say, okay, yes, we can knock off X% if you want. And they're like, yeah, okay, fine. Financial economies. Well, large firms can receive money cheaper than small firms. Right? And it's actually raise money, borrow money at a lower interest rate. Banks tend to charge a lower interest rate to larger firms as they are considered a lower risk. This reduces unit costs, okay, because they're producing the same amount, but now their costs have fallen. So as a firm grows in size, because they were paying 5% on all money borrowed, now they're paying 4%. They're still producing the same amount, but the total cost has fallen. Therefore, unit cost has fallen. And last one, specialized machinery. Higher production levels allow for the possibility of increased use of technology in production. There's a larger quantity being produced. Their cost efficiency is increased. Therefore, your average cost has fallen. And what are economies of scale? A reduction in the average cost, the cost per unit of output. Guys, thank you so much for watching. I really hope that helped, and I hope to see you in the next video.